Linear regression is one of the most popular tools in data science and machine learning for finding relationships between variables. However, you can't just blindly apply linear regression without exploring your data first. And a classic example that proves this point is Anscombe's quartet, which was created by a statistician named Francis Anscombe in 1973. So, what is Anscombe's quartet? Well, first I'll give you a quick visual down here, which is what we'll be going over. You can see we have 4 different data sets. And then let me just explain real quick. What it shows is, so it's these 4 data sets with the same mean for both x and y, the same variance, the same correlation, and the same linear regression line. But despite that, when you plot the data sets, they reveal dramatically different patterns, which we can see down here. So in these graphs, we have the same mean for both x and y, same variance, the same correlation, and the same linear regression line. But if you look at where the data points are, they are all drastically different in each case. Specifically, we can see data set 1 right here has a classic linear relationship, so actually regression works pretty well here. But in data set 2, we have a nonlinear relationship, so the linear regression line here is actually pretty misleading. In data set number 3 right here, we have one big outlier, so this one right here, which is skewing the results. And then in data set 4, we have one influential point over here that dictates the entire direction of our line. So what this quartet proves is that you can't trust summary statistics alone. You should always visualize your data before modeling, and outliers and nonlinearity can break your assumptions. So blindly fitting a linear model without checking your data can lead to incorrect conclusions, poor predictions, and unreliable insights. I want to thank you for liking and subscribing. Check out my software and courses in the description. Take it easy.